Greetings everyone, and in this series of videos which I have titled Tiny Adventures with the ATtiny, we are going to look at this microcontroller ATtiny45. We are going to see how to program its peripherals, and before getting started you need the relevant data sheet and documentation, and for that you head over to this site microchip.com and search for ATtiny45. I'll also be giving the link in the description below the video. This AT in this ATtiny45 stands for the company Atmel. This microcontroller was previously manufactured by Atmel, and after Microchip acquired Atmel, so it's now Microchip ATtiny45. Okay, so here you'll be able to download the data sheet, and do that now and save it somewhere where you can access. And there are optional documentation also, you can download if you want. I'll just briefly look at the features of this microcontroller. It's just 8-pin microcontroller. It looks like a small 741 op amp or a 555 timer, the same size package only, but it's a very powerful microcontroller. As you can see here, this microcontroller has 2 timers, one I2C, 4 ADC channels, and also SPI. I will actually program this microcontroller using this SPI pins only, and pin count is 8, out of which one pin is VCC and another pin is ground, so you will have 6 pins for GPIO. And the program memory size is 4 KB, and it also uses a 10-bit ADC. Okay, and now I've already downloaded the data sheet. We'll just take a look at the pinout of this microcontroller. So this is the package that we are going to use for this series of videos. You can see there are 8 pins, and pin 8 is VCC, pin 4 is ground. So these are your power supply pins. So there are 6 pins which I can use for GPIO. So PB0, 1, 2, 3, 4 and 5. PB here stands for port B. So in this particular microcontroller you have access only to port B, and also only 6 bits of port B, 0, 1, 2, 3, 4 and 5, 0 to 5, 6 bits of port B. And in addition, as you can see here, it has other functions like these 3 pins, pins 1, 2 and 3. They are also ADC channels, ADC 0, ADC 2, ADC 3, and then pin 7 over here, it is ADC 1. So you have 4 channels. You have an ADC, 10-bit ADC with 4 channels, and then pin 1 also acts as a reset pin. If you want, you can connect an external crystal between pins 2 and 3. They are marked XTAL1 and XTAL2. So these are the crystal pins, but we are not going to do that because already you have only 6 pins available, and if you use 2 for connecting a crystal, you will be left with only 4 pins, so I don't want that. So what we are going to do that is we are going to use an internal oscillator. We will see shortly what it is. So we are not going to connect anything over here, so we can use ADC3, ADC2, PB3, PB4 and so on. And for programming you are going to use these 6 pins: VCC, ground, and this SCK, MISO, MOSI, and reset. So this SCK, MISO, MOSI, these are pins which come under the SPI protocol, serial peripheral interface. So SCK stands for serial clock. This is master in, slave out, and master out, slave in. Okay. And you also have this SDA and SCL pins. These two pins, pin 7 and pin 5, you can use for the I2C protocol. Anyway, we will be looking at all these things as we proceed through the course. And now I want to touch upon the on-chip clock. So for that we'll just click over here, clock systems and clock distribution. So this is the AVR CPU core, and the CPU clock can be derived from a number of sources, which you can see here. External clock, you can use an external clock, or you can use a crystal oscillator or low frequency crystal oscillator, or a calibrated RC oscillator. And this calibrated RC oscillator is an internal oscillator, and that is what we are going to use for programming this, or running this microcontroller. And you can see this calibrated RC oscillator goes to the clock multiplexer and then to the clock prescaler. What happens is the system generates an 8 MHz clock internally, and that clock will be scaled down or divided by 8, so you will have access to a 1 MHz clock, which is supplied to the AVR CPU core. Okay, this information is very important when you are programming. The clock that is supplied to the AVR CPU core is a 1 MHz clock, which is derived from a 8 MHz internal clock, which has been divided by 8. Okay, and we'll just take a look at that clock. I'll just scroll down. See, here you have calibrated internal oscillator. You have two options. One is an 8 MHz clock, and another is a 6.4 MHz clock. We are going to use the 8 MHz clock only. So I'll click over here for calibrated internal oscillator, see page 27. I'm clicking on this link. So you can see here, right, 8 MHz clock, and superscript 1 over here. What does it say? It says the device is shipped with this option selected. So when you buy an ATtiny45, it is programmed to operate with the 8 MHz internal clock. And then, but you cannot use this. This 8 MHz clock is not directly supplied to the CPU. What happens is when this this microcontroller IC comes with programmed fuse bytes, and the one we are interested in is over here. See this one, CK div 8, right? So the default value of this fuse bit, this low fuse byte, bit 7 of the low fuse byte is 0. 0 means it is programmed, 1 means it is unprogrammed. So by default, the ATtiny microcontroller that you buy comes with the on-chip internal 8 MHz clock programmed, and then that internal clock is divided by 8. So the clock that you get is 8 MHz divided by 8 is 1 MHz clock. So the CPU frequency of your ATtiny microcontroller, when you don't connect any external crystal oscillator, the CPU frequency is going to be 1 MHz. And now we'll just take a look at the software tools that you need to follow along this course. For that, what you do is you can open your package manager on your system. I am on Ubuntu Linux, so I am opening the Synaptic package manager. So depending on what distribution you are using, open the relevant package manager and then search for AVR. Right, so it's going to load the packages, right? So here what you need is this thing, AVR libc. AVR libc is a standard library which you can use to program your AVR microcontrollers. It provides you a set of header files and library functions. It makes programming very easy, right? So you need this, you need to install this. I've already installed it, so it's showing as green over here. You need AVR dude, so click on AVR dude and also the AVR dude documentation. This is actually the programmer. You will use this to flash your microcontroller. Flashing means you are going to download a hex file. I'll tell you later on what a hex file is. You are going to download the hex file that you generate onto the microcontroller. So for that you need software, and that is the AVR dude. So you need to install this AVR libc, AVR dude, and also AVR dude documentation. Then these two things over here, GCC AVR and GDB AVR. GCC AVR is the compiler and GDB AVR is the debugger. So for debugging you actually need a JTAG ICE device. That is beyond the scope of this course. Maybe I will do another course which will go into more advanced concepts, and there we look at debugging. But now for this series of lectures or videos, we are not going to do any debugging. But anyway, install both GCC AVR and GDB AVR, and that should be enough, right? And there is one more thing. If you want to do simulations, right, you have these things, say simul IDE, simul AVR, sim AVR, right? So if you want, you can install these things also. So that's all about the software packages that we need. And after installing this, let's take a look at the hardware. I've actually captured videos about the hardware tools that I'm using, and I'll go through one by one. So first we'll look at the programmer, right? So this is the programmer, and this is actually called as a USB ASP programmer, right? So it has a USB port on one end which are going to plug into your PC or laptop, and it has a 10-pin connector over here to which you are going to connect FRC cable, flat ribbon cable. And then other thing is there are jumpers over here, is very important. So you can see 3.3 volt and 5 volt, right? So you can also see the ATtiny microcontroller in the background over here, right? This 8-pin package, this is a microcontroller, and this operates at 5 volt. So my jumper setting is at 5 volt, but if you use any other package, any other IC that is going to work at 3.3 volts, then you need to change this jumper setting. This is very important. But now since we are using this package, we are going to stick to this jumper setting, right? Okay, the next thing that you need is an adapter. So I told you that you need only 6 pins to program it, because you are going to program it over the SPI protocol. So let's take a look at this. So you need to connect VCC ground and then reset SCK, MISO and MOSI, right? So these are 4 and 5, 6, only 6 pins. So there is an adapter. This is optional, but it will make your life much easier. So there's an adapter, 10 pin to 6 pin adapter, which you can see over here, right? So there are also labels over here, VCC, MOSI, ground and so on, right? So all you have to do is look at the labels and look at the pinout of your IC and give connections accordingly. Okay, so you can see there are 6 holes here for connecting wires, and I have also connected my USB ASP programmer to the IC. We'll take a look at that. See, this is my programmer connected to the IC, right? So once you have done this, you are ready to flash your programmer. Okay, so this is what I want to talk about in this video, and in the next video we will look at GPIO programming. We will take a look at the data sheet, what are the GPIO ports available, and what are the registers associated with the particular GPIO port, and then how you are going to code using the C programming language, and then how you are going to compile and flash your microcontroller. Okay, so I'll see you in the next video.